Hello everyone, a very warm welcome to this video. In this video, we are going to talk about the next ecosystem project that's called as HBase. Now, if you really look at it, Hadoop is a data analysis platform and it's majorly used for batch purposes. So Hadoop is in the game to give us storage, resource management and processing. Now with this particular style or with this particular equation, Hadoop is majorly used for batch purposes. Now makers of Hadoop thought that what if we create a database where we internally use Hadoop's storage. So what we would have is a distributed database, and that database is called as HBase. So HBase is a database that uses the storage engine of Hadoop, that is HDFS. So technically we have a big database which can be used for the purpose of querying and can solve a lot of problems. So if we expand HBase, it would be name node and data node, that's HDFS, and then you have H master and H region server. So HBase is nothing but HDFS plus a DB engine for lookup. Just to give a small example, if user A was inviting user B for a movie on Facebook messaging, this use case would be catered by HBase. If Facebook wants to know about how many users have been talking about this movie, that analysis will be done in Hadoop. So if we are having a use case where we have a lot of data, but the nature of data is slightly transactional, it would be in HBase. If the nature of the analysis was OLAP or analytical, then it will go to Hadoop. That is how we have HBase. So if my RDBMS is not able to handle the data, I would go for HBase. If my data warehouse is not able to handle the data, I might go for Hadoop. That is the easiest way to look at it. So quick reiteration. If RDBMS gives up on size, then HBase is the option. If DW gives up on the size, Hadoop is the option. That's the easiest way to look at HBase. Now let's look at how HBase is different from RDBMS, traditional RDBMS databases, and let's understand how HBase works. But before we jump into any of these, let's understand that we are on the same page, that we are not promoting the fact that HBase is better than Oracle or any other database. Oracle and other databases, they are great at what they do. When it comes to HBase, it solves a different use case. So technically they are not really competitors. And the idea of the slides that we are going to draw is to convey how HBase is different, but not necessarily why HBase is better. So let's look at a couple of examples and then we will get into what exactly is HBase. So I am an organization called Amazon, and currently we have 200,000 employees, and for each employee we have personal, professional, medical details. We would like to store all of that in an Oracle DB. How many tables will we create? So we have an organization that has 200,000 employees. For each employee, the details that we have is personal, professional, and medical. And let's say we are supposed to store all of this in an Oracle DB. How many tables will we create? Now that's subjective, but typically it will be 3 or 4. It will be 3 to 4 tables that you will create. And let's look at one of the scenario. Let's take example of professional table. So we have an employee called John. He is the CEO. Let's say we have a second employee called Mark. He is a VP. But the problem is that the CEO does not have a department, but a VP does have a department that is looking for, and let's say he is VP for marketing. Now the problem is we simply can't add marketing like that. We will have to alter a table. Once we alter a table, we will end up having null here. Take third example. We have an employee called Rajesh, who happens to be a technical architect. Now Rajesh does not have a section, but Rajesh is an expert in J2EE, and that adds another nulls. Now when you look at this data, there are 3 things that are very visible, or when you store data in any RDBMS, there are 3 things visible. First thing that's absolutely visible is the fact that the structure in RDBMS table needs to be predefined. Second, nulls are stored and does cost us when joins happen. Third, data size is limited to a few terabytes. That is how Oracle works, and these are 3 limitations that we see in this particular case. Structure in RDBMS has to be predetermined. Nulls are stored and they do cost us when joins happen. And third is data size is limited. So let's see how do you deal with this in HBase. In HBase, you will actually have just one table called employee. And what you have is 3 column families like personal, professional, and medical. So our key will become employee, but in the value, we are completely free to put whatever we want. So personal, first name, John. I may not have any other detail. Second is Mark. I don't have any of his personal details, which is still okay. And I directly have his professional detail, which is his designation, and that's VP. I have another detail for Mark, which is and that's marketing. For a third employee, I can have any of the detail. So here the only thing that's fixed is your table name and the column families. What goes within a column family is completely up to the developer or somebody who's using the database, and that makes it really flexible. So let's talk of the three characters that we spoke previously. In this case, we just need to know table name and column families. Within them, everything is flexible, also called as schemaless. Second, nulls are not stored. And third, can store vast amount of data because it works on HDFS. So this is how HBase works. So HBase is a NoSQL database which is built on top of HDFS and can let you store incredible amount of data. Now let's look at a small presentation that talks about HBase. HBase is a distributed, scalable big data store. HBase is also a sorted map. It's open source. It's sparse. That means nulls are not stored. It's multi-dimensional, runs on top of HDFS, and it's modeled after Google's big table. At the very core, HBase is a map which is key and values being multidimensional. It's sorted, so when the data goes in, it is completely sorted. In our case, it was John, Mark, and Rajesh. It goes in that particular order. It's distributed. Because it's built on top of HDFS, it has the same architecture of name node and thousands of data nodes. So technically, you have a database that can span up to tens of thousands of nodes. That's the power that HBase brings to the table. It's sparse, nulls are not stored, and it's multidimensional. So you can store multiple versions of data for a same key. All that is possible. A quick comparison between HBase and RDBMS. When it comes to data layout, RDBMS is row or column oriented, whereas HBase is column family oriented. RDBMS supports transactions. HBase is limited to a single row only. Query language in RDBMS is SQL, and in HBase it is get, put, scan. Security, HBase provides you Kerberos. Indexes can be only done on key, whereas in RDBMS can be done on multiple columns. Maximum size of RDBMS is terabytes, whereas in HBase it is petabytes. Read-write throughput, RDBMS can support up to thousands of queries per second, whereas HBase can support it up to millions of queries per second because it's distributed in nature. Because it is distributed in nature. So let's look at some of the use cases as to when HBase will be used. First, you should have incredible amount of data. If you don't have a lot of data, ignore HBase completely. High read-write throughput, scalable cache capacity can cache the data, and the data layout which has key lookup. Your data should be always looked up by key. That's the way HBase works. HBase can directly be connected through MapReduce, and MapReduce can process one record at a time the way it does for normal file systems. Few use cases for HBase. WordLingo is a website that uses HBase extensively. Facebook messaging uses HBase extensively. eBay uses HBase extensively, and you have other websites using it. The point is, if your data is massive and you want to basically serve your web directly from that data, you will use HBase. When your RDBMS gives up on the size of data, HBase is your best friend. Let's spend a couple of minutes on talking about HBase data model. HBase tables, they comprise of rows and columns. Every row has a row key, and all columns in HBase belong to a particular column family. And a table can have one or more column families. Nulls are free, you don't store them. Table cells are versioned, so you can have, for a single key, you can have multiple versions of data, and they are uninterpreted arrays of bytes. So a column consists of a column family plus the qualifier. So what you can see is that user 1, we have fname and lname, and other column family is photo. So that's how you identify the entire row. Now, how does the data get stored? Physically, data is stored on a per column family basis. Empty cells are not stored, and each cell has a timestamp. So the way your data stores is, technically each column family data is stored in a single file. So if I was to search for the metadata for user 1, we are only looking at the first file. We are not even going to the photos file at all. We are not at all going towards the photos file. So how tables are designed? Now the way it works is, when you look for a same row or a single row, the way HBase stores data is, all the data for that particular row is stored on the same node. That means if you're searching something for John, all the information for John is present on that single node. And within that single node, each column family will have all its John's data in the same file. So same row key is equal to same node, and same column family is equal to same set of physical files. So if we are searching for professional details of John on a 10,000 node cluster, we are still scanning only one server, and for professional details, we are scanning only one file. That is how HBase works. How does it compare with RDBMS? We've already seen that in the previous slides. There are no concepts of joins here. An HBase table is nothing but a distributed sorted map. It's key value pairs, and it's distributed across the cluster on HDFS. Let's spend a minute talking about column families. Columns are grouped into column families. Personal, professional, medical would qualify as column family. All column family members should basically have the same prefix. Columns can be created on the fly, but column families have to be declared in the beginning. These are some of the attributes of column families. So you can specify attributes on a column family level. Like when I'm storing details about John, which are personal and professional, I can choose John's professional details or professional details for that table to be compressed. So these are some of the settings that you can have. There are more which will be in the HBase documentation. Some of the attributes. We can actually store certain data in memory and retrieve it off the memory. That's an optimization. And there is an interesting facility called time to live, where certain data may make sense only for a certain time. So you might want to store it for a certain time and then let it get deleted once the job is done. That's time to live. Now, the fundamental question would be, how can HBase let us update the data when it's running on HDFS? HDFS does not let you update the data. So how does HBase allows? Well, HBase can allow that because every new update is technically a new row that is added. And there is a concept called compaction that will clean up the old data. That's the real idea. So if John had a salary and we have updated it 2 times, the way it will work is the latest salary will be preserved and the remaining salaries will eventually get cleaned up. That is done by the process called as compaction. And another interesting feature that HBase has is the row versions. For every row, by default, 3 versions are stored. So something like John, salary 1, 2, 3. So latest is 3, but previous 2 will also be stored for your reference anytime you want. That's default. You can have more than that also. So that was HBase. In a nutshell, HBase is a database that sits on top of HDFS, lets you store amazing amount of data and serve it directly off the real-time access. And if your data is massive and you want to do analytical processing, Hadoop is the case. If you want to do some kind of retrieval as an RDBMS, HBase would be one of the options that you have. So that brings us to end of the video. Thanks for watching this video.